Lesson 13 is called changing the base. So there's this idea that whenever we don't have base 10, because remember, anytime we have something written as log to anything, it is assumed that there's a 10 here. Now, what happens if we have a log, and let's say we have a base 4, and we did not want to be in base 4, we want to go back to base 10, because remember, base 10 is what our number system is traditionally based on. Well, there's something called the change of base formula. So what that does, that says we could take whatever base that we have. So here, this is base B. That could represent a 1, a 2, a 3, a 4, a 5. And if we rewrite it such as it says this, log A represents the desired base. So we'll make a note of that. A is the desired base, which typically for us is 10. And we put that log base AX over log base A of B. We can change our base to anything that we want it to be. So what you're going to do is you're going to see us modeling this in this particular lesson when necessary. So if I look at the first one, it says number 2, and we're starting with exercise 2. It says approximate each of the following logarithms to 4 decimal places. Use the log key in your calculator rather than logarithmic tables. First, changing the base to log base 10 if necessary, right? So here we can see this is already a log base 10, right? There's no base written underneath there, so we assume it to be a 10. 3 squared is 9. So since it's already a base 10, we could just type into our calculator log base 10, 9. So we type in log, press 9, press enter, and to 4 decimal places, this is approximately 0.9542. Now if we look at this one, obviously we are not in base 10. They want us to go to base 10 before we do the calculation. So that means if I want to change base, I'm going to rewrite this as log 9, because that's what 3 squared is, over log 3, right? So just to reemphasize this, this serves as my x that we're talking about here, and this 3 here serves as my b, which is written here. That's how we get to log 9, log 3. And so now in each of these cases, my little base is 10. So we can go to my calculator, and then we can type in log 9, and we can divide that by log 3. And we find out the answer to this is simply a 2. So same idea over here. We have a log base 2 of 3 to the squared power. We want to be log base 10. So we're going to apply the change of base. So this would be log 9 over log 2. So we go to our calculator, we type in log 9, we divide that by log 2, and we get approximately 3.1699 to 4 places behind the decimal. And so what you're doing is you're just observing the change of base mechanism being done, so we can change the base 10 and make the log key on your calculator work properly. So number 3 is not something that we're going to solve. These are properties. They say you can explain things about these, but what I want you to note is just what the properties are. So we'll review them. These are the same properties we talked about in lesson 12. They just took the 10 off. And so in this one, now they're saying log base b of 1 is always equal to 0. If these two values are the same, then it's equal to 1. If we've got a base and a piece the same, that's equal to the exponent of r. That's more in general. That's a general version of b. Same thing you can see with d. If you have a base raised to a log b and these two are the same, then the answer is just x itself. And then you've got these properties here, where the product of anything is the addition. You could take this r and move it out to the front, make it a product. If you have a 1 over x, right, it becomes negative times a log, and you can move that x to the numerator. If you have division, you replace it with a minus sign. So those are the properties. Again, we'll model a couple of those in a minute. They are on a lesson summary at the very back of this section. You want to use that as a reference chart as you go through some of these and get some practice in on what these are going to look like. In addition to that, they're going to bring in this new thing called a natural log. So that's ln. Now, don't be alarmed by this. ln is like saying I had a log with a base e. E is one of our keys on the calculator. It's right above natural log. It says e to the x power. And so what they do is they just, whenever we have a log base e, we replace that with ln. So what they're going to ask us to do is just go through these and use the ln key or the log key. That way you can find them in the calculator and find each value to 4 decimal places. So if we did the natural log of 1, that would be 0.0000. It's 0, in other words. If we compare that to log base 10 of 1, that would still be 0. If we did natural log of 3, that would be equal to 1.0986. And again, remember, you're putting it in the calculator. If I did log base 10 of 3, that would be 0.4771. If I did the natural log of 10, that would be 2.3026. Compare that to log base 10 of 10, that would be 1.0000. If we did natural log of 25, that would be 3.2189. Compare it to the log base 10 of 25, it's 1.3979. If we did the natural log of 100, that would be 4.6052, compared to this being a 2 in that perspective. So in general, what you find out is these over here are generally larger than or equal to their log base 10 counterparts, right? That's what actually number 5 is about. They say to make a conjecture and compare these two together, and we tend to say that the natural log of x is greater than or equal to its log base 10 counterpart. In that perspective, we're not going to look at number 6, so we're going to skip past that. And so what they want us to do is the same kind of idea we did in the last section. They want us to write these as a single logarithm. So we do have to look at characteristics. We have a minus sign, which is going to indicate division, a plus sign, which is going to indicate multiplication, and we also have a product of 3 to a natural log right here. And so the same idea is going to play out in each of these perspectives. And so let's see, we can rewrite this, get this color here. So we can do, this is 3 to the 3rd power, right? So if we set this equal and do one thing at a time, the natural log of 4 minus, what we're going to do is pull that 3 in. So we're going to have a 1/3 to the 3rd power. And then we're going to add a natural log of 2. So if we did that, 1 to the 3rd power is 3, and then 3 to the 3rd power is 27. So now what we end up with is we end up with the natural log of 4 minus the natural log of 1 over 27 plus the natural log of 2. That means this is going to say the natural log of 4 divided by 1 over 27. We'll calculate that in a minute. We're going to take it one step at a time. As you get better, you can combine steps. So if we did 4 divided by 1 over 27 is the same thing as saying 4 times 27. And so we end up with 108. And so you get the natural log of 108 plus the natural log of 2, and then we could multiply these two together. And so 108 times 2, and you get 216. And we've written that as a single logarithm. You don't have to simplify it any further. The author in the book suggests that this 216 can be rewritten as 6 to the 3rd power, and you could pull the 3 out as such. If you see that, that's great. If not, we're not going to get too worried about that. So now if we look at letter B, same idea. We're going to move this 3/5 to the inside. So that'll go to there. So we can write that the natural log of 5 plus the natural log of 32 to the 3/5 power minus the natural log of 4. So 32 to the 3/5 power is going to be 8. So now I got the natural log of 5 plus the natural log of 8 minus the natural log of 4. For those who want a background, I just did this in the calculator, but remember, you could rewrite that as the 5th root of 32, and then I can raise that to the 3rd power. Turns out the 5th root of 32 is 2, and 2 to the 3rd power is 8. That's how that's actually calculated without picking up a calculator. So since this is a plus sign, we can multiply this. So you get the natural log of 5 times 8, which is 40. And if we see a minus sign, that means division. So as a natural log, you get 40 divided by 4. So 40 divided by 4 is 10. So you get the natural log of 10. And then in number 8, they want us to go the opposite direction. They want us to expand these logarithms. So we see we have a radical over all of this. So all of this is going to get a 1/2. And then you're going to get a division, so as a minus sign, when you get an e squared. So if we start with this, we would do the natural log, and we would say 5 to the 1/2 power plus the natural log of x to the 3/2 power, that's the numerator, and then minus the natural log of e squared. Now we're not done expanding this out. We're going to move these 1/2 to the front, so we're going to end up with 1/2 natural log of 5 plus 3/2 natural log of x, and we're going to move this 2 out to the front, so minus 2 natural log of e, but ln e is equal to 1, and so my final answer is 1/2 natural log of 5 plus 3/2 natural log of x, and then minus 2. So while this one may seem complicated, it's really not that bad. the x plus y part's really irrelevant. So we rewrite this as the natural log, and I'm going to put, for not so many parentheses, I'm going to use brackets. And we put a minus sign because there's division, and then we do the natural log of x squared plus y squared. We're going to take this 2 and move it out front, so 2 times the natural log of x plus y, and then minus, because these are both squares with a plus sign, there's nothing I can do there, and so it just stays exactly as that. Okay, so that's this lesson. So you got to see the change of base, you got introduced to the natural log, and we practiced again condensing and expanding logarithms.